Oh, good morning, everyone. This is going to remind me of my college days out at both Shippensburg, Harrisburg Area Community College, and RPI. Is in this time of year comes around, the groundskeepers would start working on the grounds, and I know RPI, not all the classrooms are air conditioned, so we'd sometimes have the windows open, and you would hear the sound of, well, in this case, leaf blowers or power tools in the background, and mowers. And I've got a neighbor, a couple houses over, that's doing some yard work, and so you might hear some of the motors revving up in the background there, and it's funny. I just that's how I remember spring campuses. Odd, right? Like, I went to school late for my age, so when I say remembering school campuses, I'm not talking about the 1990s. I'm talking about, like, the 2007s and 2010s, which is within a decade in general. All right. I hope everyone's doing well. I will be sending out my T-Day email tonight with where the due dates are at, what we have there, and a list of what's in the video sections within the playlist. I'm also going to start chasing up on quizzes and exams. Again, if you have any questions, holler. One thing to be noted, we've had a couple of random people come in the last two classes, and hey, Billy, and just ask weird questions. I block them as soon as I see them. Such is the way of the internet. So I was, before the recent Zoom security issues, I was aware of other security issues with Zoom, so I wasn't a big fan of Zoom. Kind of happy I didn't go there, because the one exploit was allowing it to grab things off of people's Windows computers directly, so I didn't want to expose anyone that way. All right, so the T-Day emails will go out. There might be some motor noises in the background. That's everything I have that is administratively of a concern. If you need anything, please email me. Please keep speaking with me. Communication is the key here. I know this part is fairly unidirectional. You have been doing an amazing job using the chat feature to ask questions. And we will adapt as needed. I'm trying to get videos out based off the questions that come through an email, and I've started putting up examples. I did some examples of how to use Desmos to look at the extrema for sections 4.1 and 4.2. I would highly recommend, if you are not comfortable with your graphing calculator or another graphing utility, or you don't have one, to use Desmos as your graphing calculator for now. All right. That being said, let me switch over here, and we're going to continue our idea of division. And what we're looking at in division is our end goal is to factor things. We want to build crazy large polynomials, and then we want to break them down into their pieces. And to do that, what we're going to do is we're looking for factors which are usually in the form of x minus k. And so when we divide, I have some polynomial here. I'll just write it in its general form. See, there's that background. Looks like they're getting the bushes between the house. Sorry about that. And we're going to divide it in a long division by x minus k, this will break this down into a simpler polynomial. Now, this is something we usually have to repeat for each factor. So we're going to find tricks to focus on the factors. And one of the things about this is x is not squared in this case, and x is not cubed in the divisor. And so the things that really become important are k, which is the root, the zero, or the solution. Right? Whatever the value of k is called the root, the zero, or the solution, and we'll definitely be expanding more into that shortly. Or the whole thing, x minus k, is a factor. And specifically, it's a linear factor because x to the first power is a linear term. So if we're looking for linear factors, we can focus on the k. The thing that drives the polynomial is the degree of the polynomial and the coefficients. So, coefficients, I'll put coefficients here. So there is a technique for focusing on the coefficients that saves some of the hassle, and that's called synthetic division. Now, again, I'm going to stress the thing you need to divide by needs to be linear. You need to have x to the first degree for the factor, or this won't work. So if I give you a division and x is squared, you're going to need to do long division. But if I give you a division where it is a linear factor, then you can do synthetic division. And synthetic division, by focusing on the coefficients, can go a little bit faster. So let's look at a synthetic division here and get the rules. So what we want to do is we write k to the left of the coefficients. Coefficients of f of x. In the top row. If any powers of x are missing, we put in 0. And that's what we did for long division. We put in 0 for any powers of x that are missing. So what I'm going to do here, let's see, I'm going to scroll this up here. I've got 3 little rules I want to do. So right at the bottom, I'm going to write my f of x. Well, let me write the rules as we go. Let's see here. Yeah, board space. So I'm going to divide 2x cubed plus 4x squared minus x plus 5. I'm going to divide it by the linear factor x plus 2. So I want to write k to the left of the coefficient. So step 1, I'm going to write negative 2. Notice k in this case is negative 2 because it's x minus k, and for this to be positive, k had to be negative 2. Then I'm going to write the coefficients over here in my top row. So there's 2, 4, negative 1, and 5. Notice how x is not in my rules here. All right. And then for number 2, we drop the leading coefficient down. Oops, I keep missing that en coefficient today. Remember, math teacher, not English teacher, so spelling is not my same. Down to our third row. Multiply this number by k, and write this in the second row. So I'm going to do this in red here. I'm going to scroll back up to these synthetic divisions. The rules are on page 297 in the book. The book kind of does this as 3 rows. I'm used to this being like 8 rows, just kind of like long division. Eight does this in three steps. For me, this is step 1. This would be step 2. This would be step 3. This would be step 4. Right? Steps are a weird thing sometimes. So what we mean by dropping this down is I'm going to put a line here, and I drop the 2 down. So it comes straight down, and I'm going to multiply these. Negative 2 times 2 is negative 4. And so that's what it means by drop the leading coefficient down to our third row, multiply this by a number by k, and write this in the second row. Add these numbers. And repeat until out of coefficients. So if I add these numbers, I get 0. 4 and negative 4 is 0. Now I'm going to repeat, so I'll repeat in red here. Negative 2 times 0 is 0. So I drop this down, I multiplied, let me drop this down, I multiplied to get this number, I added, I multiplied to get this number, I add. I'm going to multiply again, negative 2 times negative 1 is positive 2, and 2 plus 5 is 7. And I'm done. The last number is my remainder. And the first number is my coefficient of x to n minus 1. So in this case, my n was 3. So this is 2x squared plus 0x minus 1 with a remainder of 7. And so I'll write my remainder like this. Whoops, it's the wrong thing on the bottom, isn't it? I divided by x plus 2. This is 7 over x plus 2. Has to be by my divisor. I'm so happy I got done. This works out really nicely on paper underneath long division. It's only limited by we have to use this. So let me do another example here. But I want to do a couple examples of this. Synthetic division is worth seeing some examples coming through. This is something that if you continue in STEM or mathematics, you will start seeing a lot of techniques that focus on coefficients. The coefficients of equations tell you what's going on. They are able to show you everything about it. We know x, and we know x is going to be in descending order by the way we set this up. So the only thing that really has any definition that's differentiating this from any other cubic are the coefficients. So there's a lot of techniques that focus on just the coefficients, because we know what the other properties are. So I'm going to do, I'll actually do a handful of synthetic divisions so that we can get used to it. And I'll have to remember that in my remainder goes over my divisor, not over my dividend, right? Let's come over here. So let's do another one. So let's see here. This is 2x squared minus 4x squared. So 2x squared minus 4x squared minus 1 that I'm going to divide by x plus 1. So when I set up, oops, it's the first term here is cubed. So 2x cubed minus 4x squared minus 1. So I actually write my coefficients first, and then I'll put my k out to the left. So I have 2, negative 4, but notice I'm missing a term for the x. So 2, negative 4, 0 for the x, and negative 1. And my k here is a negative 1. So there I have converted my dividend into coefficients, and I have pulled my k out front. So I'm going to start by pulling this straight down and multiplying by negative 1. Negative 1 times 2 is negative 2. This gives me negative, I miss a sign here. This gives me negative 6. Double checking my signs. And then a negative 1 times negative 6 is positive 6. And I add these. And negative 1 times 6 is negative 6. So it's this negative 1 multiplies by everything here, and we kind of get this bouncing pattern where the multiplications create the next thing over. Kind of bounces. And negative 6 plus negative 1 is negative 7. This is my remainder. And this is to a power 1 less. So that's 2x squared minus, because the negative sign, 6x plus 6 minus 7 over this. See how this goes much more quickly than long division? It only works in the limited case if what you're dividing by is a linear factor. You have to remember to switch the sign here. Now, once we start learning roots and how roots work with different factors, that sign switching won't be too bad, because I'll call this thing the root or the 0. And we'll keep the sign of that. Signs are something we have to be aware of. If you notice, like, my big mistakes have been with the signs, and the thing I'm double checking when I'm going through is I'm going to check my signs, All right, like I said, I'm gonna do a handful of these, so that we can do some, just get a feel for this technique. It is much quicker than long division. It is limited. My repeat of the day, linear factor. So x is only to the power of 1. Watch your signs. Let's come up here and do another one. And I'm going to dig a little deeper in the book. Instead of just doing the examples they have, I'm going to do something to a higher order. And I want to do something without a remainder, because I've been doing things with a remainder. So I'm going to do x to the 5th plus x to the 4th plus 2x plus 2. And I'm going to divide that by the linear factor of x plus 1. So my first step is I'm going to take the coefficients of this and write this, the coefficients only, paying attention to the powers of x that I do not have. And And so I have 1 for my first coefficient. For the 5th power. Come down to the 4th power, I have 1. Come down to the 3rd power, I've got a 0. Come down to the 2nd power, I still have a 0. First power, 2. And the constant is 2. And so these coefficients represent my dividend, the thing that I am dividing. Now if I take my divisor, my k is -1. So I come over here and I write -1. Draw my line. This will come straight down. And so I get a 1. -1 times 1 is -1. These give me a 0. -1 times 0 is 0. I add these, I get a 0. -1 times 0 is 0. I add these, I get a 0. -1 times 0 is 0. I add these, I get a 2. -1 times 2 is -2. I get a 0. That's my remainder, the last one. And my first term is this to 1 less power. So I have 1 x to the 4th plus 0 x cubed plus 0 x squared plus 0 x plus 2. Right? There's x to the 4th, x cubed, x squared, x, the constant, the remainder. Well, we don't write our zeros, so this is x to the 4th plus 2. And I'm going to do one more synthetic division. I'll do one here with fractions, because I think this helps show our fractions, how fractions can be done easier with this, because they don't multiply to every term like they would in long division. So let me change to a happy color. So I have x to the 4th minus 1/2 x cubed plus 3x squared minus 5/2 x plus 9/2. And I'm going to divide this by x to the -1/2. And actually looking at this, I would not want to do this with long division. Every time I'd multiply it by through, I'd be having this -1/2 term, -1/2 term coming across all my x's. But if I take my coefficients here, let's say I have 4, 3, 2, 1, 0. So I don't have any blank coefficients. So I'll write all of the coefficients here. So this is for the x to the 4th term. This is to the x to the 3rd term. This is for the x to the 2nd term. This is to the x to the 1st term. And that's the constant. I'll take my k, which is a positive 1/2. Again, watch our signs here. This is x minus k. So this comes through as a positive. Line here. I'm going to keep my calculator with me here because I think some of these calculations will be neat. So I'll bring down my 1. And 1/2 times 1 is 1/2. -1/2 plus 1/2 is 0. 1/2 times 0 is 0. I'll add these. I get 3. 1/2 times 3 is 3/2. And 5/2, negative 5/2 plus 3/2 is negative 2/2. But we know negative 2/2 as 1. 1/2 times negative 1 is negative 1/2. 9/2 minus 1/2. Well, 9 minus 1 is 8, and 8/2 is positive 4. So notice how it's compact. It does leave us room to do the additions and subtractions off to the side. And synthetic division can help us with these factoring. So let's see. This is x cubed. That would be your x squared term. That would be the x term. There would be our constant. And then I'll take our remainder and write it off on the end there. And so this is the technique for synthetic division. All right, let's go through and look at putting all this together. Give me 1 second here. I want to make sure, nope, that's not showing the thing that it needs to. Give me 1 second. There we go. All right, so let's look at this in our larger picture. We've been dividing and talking